use the row reduction algorithm to solve the linear system. And so we have a linear system here with three beautiful equations. And thinking about our row reduction algorithm, we know we want to begin by using the x sub 1 term in equation 1 to eliminate the x sub 1 terms in the equations below it. So we only have an x sub 1 term in equation 1 and 2. So how are we going to eliminate x sub 1 from equation 2? Well, if we multiply equation 1 by a scalar multiple of -1, and then add this to equation 2, we'll be able to attain a new and reduced equation 2. So let's give it a go. We have the first equation will remain as it is. We have x sub 1 plus x sub 2 plus x sub 3 is equal to 6. And now just be careful here as you are manipulating this that we have to multiply the entirety of equation 1 by a scalar multiple of -1. So this negative needs to be distributed to each term in the linear equation on both sides. So here we go. We have minus x sub 1 plus x sub 1, which goes to 0. We'll then have minus x sub 2 plus 0 for a minus x sub 2. We have a minus x sub 3 minus x sub 3 for a minus 2x sub 3. And that will be equal to minus 6 minus 2 for a minus 8. And then equation 3 is going to remain as it is. X sub 2 plus 3x sub 3 is equal to 1. And so looking at this system, we have eliminated all of all of the x sub 1 terms, and we're ready now to move to equation 2 and think about the x sub 2 term. So we want to use this pivot position to eliminate the x sub 2 below it. So we lucked out here. We just simply need to add these two equations together. So if we add the given equation 2 to equation 3, we will end up with the new and reduced equation 3. So here we go. Equation 1 still remains as it is. X sub 1 plus x sub 2 plus x sub 3 is equal to 6. Equation 2 will remain as it is. Minus x sub 2 minus 2x sub 3 is equal to -8. And now we're adding equation 2 to equation 3. So we have minus x sub 2 plus x sub 2, which gives us 0. We have minus 2x sub 3 plus 3x sub 3, which leaves us with x sub 3. And last but not least, we have minus 8 plus 1, which is equal to -7. So this is our new equivalent reduced system. So notice here, looking at this reduced system, that we have attained a triangular form. So we can solve now using back substitution. But before we do that, I want to look at one more row operation here. Looking at equation 2, notice that each term in this equation has a scalar multiple of -1. So we can even make this nicer by multiplying equation 2 by a scalar multiple, or we're actually scaling equation 2 by -1. And so this reduces the system to x sub 1 plus x sub 2 plus x sub 3 equals 6. Equation 2 now becomes x sub 2 plus 2x sub 3 is equal to +8. And our third equation is x sub 3 equals -7. So that last step there is optional. You'll get the same answer either way, but it's always nicer to work with positive numbers. All right, so again, we have attained the upper triangular form here, and we're ready to solve by back substitution. So to back substitute, we are taking x sub 3 equals -7 and plugging it back into the equation above it. So we're going to use this to solve for x sub 2. So we're solving by back substitution. and I'll abbreviate back sub. All right, so we are taking x sub 3 is equal to negative 7 and plugging it into equation 2. And let's actually give ourselves plenty of room here. So here we go. We have x sub 2 plus 2 multiplied by x sub 3. So that's going to be multiplied by negative 7 is equal to 8. So this leaves us with, we have x sub 2 minus 14 is equal to 8. And adding 14 to both sides, we're left with x sub 2 is equal to 22. Woohoo! So now we have x sub 3 is equal to negative 7, and we have x sub 2 is equal to 22. So we'll take both of these terms and back substitute them into equation 1 to find x sub 1. So equation 1 is x sub 1 plus x sub 2, which we just found to be 22, plus x sub 3, which we found to be negative 7, and that's, of course, equal to 6. So now we're ready to solve for x sub 1. So we have x sub 1 plus 15 is equal to 6, and then subtracting 15 from both sides of the equation, we see that x sub 1 is going to be equal to negative 9. And we've done it. We have all three entries, and we can say that therefore vector x, the solution vector in 3 dimensions, is defined. Again, we define this as a column vector, x sub 1, x sub 2, x sub 3. And this is going to be equal to negative 9, 22, minus 7. And so this is our beautiful final answer to the system. And now what's great about algebra is that we can always check our work. Right? So let's go ahead and make sure that this is, in fact, the correct answer to our system. Alrighty, so let's make sure that our algebra is accurate by double checking our work. So to check our potential solution, we need to substitute this potential solution into the original linear system to make sure that each equation still holds true. So here we go. Equation number 1. We have x sub 1 plus x sub 2 plus x sub 3 equals 6. I don't know, let's find out. So we have negative 9 plus a positive 22 plus negative 7. And we want to know, does this equal 6? So we have, let's see, 22 minus 16, which equals 6. Woohoo! So far, so good. Equation 2. Let's see, we have negative 9 minus a minus 7. And we want to know, is this equal to minus 2? I don't know. Let's find out. So we got negative 9 plus 7, which equals negative 2. Woohoo! Last but not least, equation 3. We have x sub 2, so we have 22 plus 3 times x sub 3, so that's 3 times negative 7. And we want to know, is this equal to 1? So we have 22 minus 21, which equals 1. Woohoo! So we have officially confirmed that this is not a potential solution, but is the only solution. It is the correct solution. So it takes an extra 60 seconds max to check, but guarantees that you get 100 on every homework question, quiz question, or test question.